After shall we start, sir? Let the participants come and join later.
Yes, ma'am. Yes, sir. Yes, sir.
Okay, sir. Chandi, ma'am,
Sir.
let me start the session, ma'am.
Okay.
Yeah, Sadia.
Yes, sir.
Yes, you can start, ma.
Yeah, okay, sir.
Yeah.
Good evening, everyone. Assalamu alaikum and a very warm welcome to all. On behalf of MEASI Institute of Information Technology, I'm delighted to welcome you all to today's webinar on the modern software factory, understanding DevOps and the power of Kubernetes. I extend my warm greetings to all the participants, respected faculty members, and our esteemed guest speaker who have joined us today. To begin this session on a blessed note, let us start with the recitation of the Holy Quran. I would like to invite Umaira for the Kirat.
Assalamu alaikum rahmatullahi wa barakatuhu. أعوذ بالله من الشيطان الرجيم. بسم الله الرحمن الرحيم. والتين والزيتون وطور سينين وهذا البلد الأمين. لقد خلقنا الإنسان في أحسن تقويم ثم رددناه أسفل سافلين إلا الذين آمنوا وعملوا الصالحات فلهم أجر غير ممنون. فما يكذبك بعد بالدين أليس الله بأحكم الحاكمين. Translation: by the fig and the olive, and by the Mount Sinai, and by the sincere city, indeed we create man in the best form. Then we return him to the lowest of the low, except those who believe and do righteous deeds, for they will have a reward that never ends. So what it cautious you to deny the recompenses? Is not Allah the most just of judges? Jazakumullahu khair.
Thank you, Umaira, for the beautiful recitation. Now I would like to invite Leena Bushra to deliver the welcome address.
Good evening, everyone. On behalf of MEASI Institute of Information Technology, I warmly welcome you all to today's webinar on the modern software factory, understanding DevOps and the power of Kubernetes. I extend my heartfelt welcome to our respected speaker, Ms. Chandi, Rani, Janardhanam, and to all the students who have joined this session today. I hope this webinar will be an insightful and enriching learning experience for everyone. Thank you all for joining.
Thank you.
Thank you, Leena, for the warm and gracious welcome. Next, to give us a brief overview about our institution, I would like to invite Dr. Sabarish to speak about the college.
Thank you, Sadia. A very warm good evening to everyone present here. It's my pleasure to introduce about MEASI Institute of Information Technology, a premier institution committed to academic excellence, innovation, and industry-oriented education. MEASI Institute of Information Technology, popularly known as MEASI IT, has been consistently nurturing young minds by providing quality education in the field of information technology, computer science, and applications. The institution focuses not only on academic knowledge but also on the developing practical skills that prepare students for the real-world challenges. One of the major strengths of our institute is our well-equipped laboratory facilities. Our labs are designed to provide hands-on learning experiences in areas such as programming, artificial intelligence, networking, data analytics, and software development. These labs enable students to experiment, innovate, and develop technical competencies required in today's digital world. We also host centers of excellence which serve as specialized hubs for advanced learning and research. These centers encourage students to explore emerging technologies, work on innovative ideas, and collaborate interdisciplinary projects that address real-world problems. Another unique feature of MEASI IT is a focus on in-house real-time client projects. Students actively participate in developing real-world applications, software solutions, and research-based projects within the institution. This exposure helps them to gain practical experience, build strong portfolios, and enhance their employability before they even graduate. When it comes to the higher education, our institution also supports in offering attractive and affordable admission fee structures for the TANSET qualified candidates, making quality postgraduate education accessible and encouraging meritorious students to pursue advanced studies in technology. At MIASI IT, we strongly believe in bridging the gap between academics and industry, ensuring that our students graduate with the knowledge and confidence needed to succeed in the modern technological landscape. We warmly invite the aspiring students to join MIASI Institute of Information Technology and become part of the dynamic learning community where innovation, research, and career development go hand in hand. Thank you.
Thank you, sir, for sharing those insights about our institution. Now it's time to introduce our guest speaker for today's webinar. I invite Shafika to deliver the introduction of the speaker.
Good evening, everyone. It is my pleasure to introduce our esteemed guest, Ms. Chandi Rani Janardhanam. She has over 10 years of professional experience in both teaching and the software industry. She has worked extensively in the field of software testing, including both manual and automation testing, with hands-on experience in tools like Selenium, Java, SQL, and Jira. She has also worked as an associate at Cognizant Technologies where she contributed to projects related to health insurance system and automation testing. Currently, she is working as a React Native developer at Sourcelantics India Private Limited, focusing on mobile application development and user interface design for Android and iOS platforms. Apart from her industry experience, she has also served as an assistant professor in several colleges, sharing her knowledge with students and shaping future IT professionals. Her strong expertise in software development, testing, and mobile application technologies makes her an inspiring speaker for today's seminar. Once again, we welcome you, ma'am.
Thank you. Thanks a lot for a wonderful introduction.
Thank you, Shafika, for the introduction. Now we move on to the most awaited part of today's program, the webinar session on the modern software factory. I request our respected speaker to kindly take over the session.
Thank you, Sadia.
Thank you.
Give me a minute. Let me share my screen. Okay. Am I audible?
Yes, ma'am. Yes, ma'am. It's audible.
Okay, before starting, I would like to express my sincere thanks and respect to the Director, Madam, Dr. Usha M, and the Head of the Department, Dr. Vimalapriya MD, and all the assistant professors joining us today. Thank you for inviting me to share this industry insights with the students. And for the students, I know it's sitting through 1.5 hour session can be challenging, but today we are not just talking about the theory. Today we are going to talking about the skills that we get hired in 2026. Okay, let's quickly jump into the session. So before starting our slides, I would like to ask a small question with you. So if you are okay, then you could please post a emoji, hands up emoji, or a simple message on the chat window. Okay. How many of you are using Instagram, Spotify, Netflix, and so on social medias? Is there any response for that? No one is using. Okay, good. Okay, thank you. So, have you ever had a situation that these Netflix, Spotify, and Instagram, all the apps go for a a while for maintenance? Have you ever experienced a maintenance downtime for these apps? Do we have maintenance downtime for these apps? Amazon, Flipkart. So most of these apps, right, we don't have downtime because they are using a new methodology called agile methodology. So using that methodology, Amazon, Flipkart, Instagram, all the apps, right, what they are doing, each and every day, they are upgrading their code 1,000 times per day. Do we have any downtime in per day? No. Most of the answers will be no, because they are using agile methodology. So we'll see depth in later. First, start with modern software factory, understanding DevOps, and the power of through the power of Kubernetes. So today agenda about the slides. The first, the mindset, why we move from waterfall to DevOps. We all know what is waterfall model. Mostly software engineers use waterfall model in olden days, but now we have introduced a new method called DevOps. We'll see how it is interchanged from waterfall to DevOps. And the next topic we are going to see in this slides seminar is the box. What is Docker container? So through Docker only, they are going to achieve the DevOps concept. And the brain, how does Kubernetes manage the cloud? So everything will be, whatever it may be, DevOps, Agile, or Docker, everything is going to be handled inside this Kubernetes. Kubernetes is the brain which is going to send the instruction to each and every app. Okay. So the next, how this Kubernetes will work? The Kubernetes will work with the help of a language called YAML. Yet another markup language is a language which understand by this Kubernetes to execute this DevOps and Dockers. Okay, next move to the next slide. So, am I too fast?
No, ma'am, no.
Okay, so let's start with the traditional model, waterfall model. So this is the diagram of traditional model. Requirements, design phase, development, testing, deploying, maintenance. We all know, we all studied this waterfall model in our software engineering. Okay, so requirement phase, what we'll do? In requirement phase, we supposed to gather all the information regarding our project, what the expectation of the client. So customer, we need to get whatever relevant information we need for our project. We need to get everything from the customer at the requirement stage itself. Once we complete the stage, then only we can move to the next stage. Are you getting? So requirement stage, we need to collect all the details and we need to document it in waterfall model. Okay, document plays a vital role in waterfall model. With the help of document only, we can move next phase by phase. So first we need to complete this requirement stage where you need to collect the entire information, whatever information, either it may be a dump information or useful information, whatever you are getting, so whatever you are having doubts, you can clarify in this requirement stage itself. The next stage, once you complete the stage, you are going to document it. It might be some hundreds or 1,000 pages document. The next page, using that document, you are going to design phase. In design phase, what you are going to do? In design phase, we are going to analyze what type of language we are supposed to use, what type of database, which architecture is best for this project. So we need to analyze all these items in this design phase, and we are going to propose whatever requirements we are gathered in terms of use case diagrams, data flow diagrams, flow charts, whatever diagram is applicable for us, whatever is understandable by us, we are going to implement in that types of designs. Okay. And so in design, before moving to development, we need to complete everything in design phase. Once we move out of this, we can't revert back. Okay. If you want to move any changes, again, you need to start from the requirement and then you need to perform design. Once you complete the design 100%, then you are going to development state. In development state, what you are going to do? The actual coding part. In this development, not only coding, we are having infrastructure team. N number of teams are there in a project. Okay. All teams are going to work individually. There is no interconnection between the database team, infrastructure team, and the coding team. Okay. Each and every team is going to work neutrally. There is no interconnection between them in waterfall model. Are you getting? Am I confusing? Sorry. So once the code is developed and the data structure, database, infrastructure, API services, if everything is set right, then we are moving to the next phase is testing. So once testing is done, in testing, the development team will also perform the unit testing. Once everything is done, there will be a testing team, especially selected for this testing purpose. They will perform some n number of testing, unit testing, integration testing, end-to-end testing, performance testing, load testing, like that. There will be some n number of testing. All the testing, it should be passed. If any test get failed, then the main drawback in this waterfall, then again, they need to go for requirement stage. Again, they need to sit with the client and they need to get a clarification from the clients. And again, they need to rework whatever design already they designed, that is not going to be work now. They are going to restart the work and again restart to development and testing. So once everything is done here, then they will go for deploying. So here, what the problem is, in development, they might be done the code before 6 months. Okay. Before 6 months, they have completed the coding part. And now after 6 months, they are going to deploy at the client side. The product is ready and they tested everything and everything is working fine in the stage, testing stage. Now they are going to deploy this product at the client side. Are you getting? So while deploying that, there will be a gap of 6 months between development and deploying. Some version of code has been changed. So while deploying, most probably we could face an issue. So what will happen? Whatever time we spend, whatever effort we spend in this project is entirely going to be waste. Again, they are going to start from the requirement, design, development, testing. So this is a time-consuming model. Waterfall model is a time-consuming model, but this is the best model for if the project is a long-term project. Are you getting? If a project is a long-term project, then it is the best model. Whereas if a project is a small project, and if you are doing this using waterfall model, it will be a time waste. Are you getting? So the classic approach to software development, it follows a linear sequential path. Like a real waterfall, the water flows only downwards. You cannot go backwards to get clarified, to clear that, to fix that, and you can next come. Okay, you cannot do that. So once you complete the previous stage 100%, then only you can move to the next stage. Okay, this is, and the phases, requirements, gathering all the info from the client, design, planning the architecture, implementation, the actual coding, verification, testing, checking for the bugs, maintenance, releasing and fixing issues. Okay, I think you all have some idea about waterfall now. So now move to the drawbacks, the disadvantage of waterfall model. If you find a bug in the verification stage, you have to go all the way back to the start. Just now I explained you regarding this. It's like building a 50-story building and realizing the foundation is weak when you are on the roof. So this is entirely an effort loss only. Okay. So the big bang release. So long wait time. If your project is small, why should we wait for a long time, 6 to 12 months? Okay, it's a big issue in waterfall model. Software is only delivered at the very end of the cycle, which could take 6 to 12 months. And high risk, because everything is released at once. If one small part fails, the entire system crashes. And the another main disadvantage is it worked on my machine syndrome. Environment mismatch, because testing happens so late. Developers often write code in an environment that is totally different from the production server. The result, integration hell, spending weeks trying to make the code run on the actual servers. So in the maintenance stage, we can't, that production, right? One second. So in the deployment, if we are going to waste n number of days by fixing the issues, because development of code has happened some around 3 months before, and now after 3 months we are deploying the code. So there will be versioning issues, library issues, everything will be happen. So we can't able to identify where the actual error happened, where we need to fix that bugs. Okay. So in that finding, we are supposed to waste n number of days. So these are the main disadvantage of waterfall model. But the advantage is, if the project is a long-term project, the best model is waterfall model. If a project is a short-term project, then it is not optimal for that short-term projects. Now moving to the agile methodology, which is a modern software methodology. Okay, so agile methodology. Agile methodology is known as iterative development. So here the same phases only. We are going to requirement gathering, design, develop, test, release, and maintenance. Everything the same. Waterfall, whatever we are following in waterfall, the same thing we are going to follow here also. But the only thing is, it is an iterative development. Or getting, it is an iterative development. What it means is, for example, if you are going to develop an app for Amazon, okay, so for Amazon we are going to develop an Android app. So in that Android app, first we can start with the login page. Are you getting? First we'll start with instead of creating the entire project in a one stretch of 1 year or 2 years, what we are going to take is, we are going to break the biggest project into small chunks, which can be handled. Okay, that chunks to be handled in that sprint. Okay, sprint is nothing but 2 weeks, or some companies use 2 weeks of time to release, or some companies use 4 weeks of time. This duration is known as sprint. Okay, so for every sprint they will release some software which will be working software. Or getting, instead of waiting for 12 months to get a software live, in agile methodology, what we are going to do, for every 2 weeks, we are going to give a live to a software. It may be a small, minor improvement. Are you getting? So the core concept here is iterative development. The core idea, break the big project into small, and that small is be manageable chunks called sprints. And usually the sprints of 2 to 4 weeks. Some companies follow 2-week sprint, which is of 14 days, and some companies follow 16 days sprint. Okay, and instead of every 6 months, we'll use to release project every 2 to 4 weeks, and continuous feedback. Whereas in waterfall, once during the requirement gather only, we could able to communicate with the customer. Customer means client, who is going to give project to us. Okay, only the initial stage. And once we complete everything during maintenance or deploying stage only, we are going to again communicate with the customer. In between, we don't have any communication between the customer and the team members. Okay, whereas here, every week we are going to get feedback from the, before release, every week we are going to get the feedback from the client, and then only we are going to release our product. Are you getting? Continuous feedback. The customer sees the progress early and can ask for changes immediately. Okay, the next, the core process, the sprint. The work is broken down into small cycles called sprints, usually 2 weeks long. Plan, the plan state, design, develop, test, release, feedback. So plan, pick 3 small features to build. I told you, right? If we are going to develop for an Amazon and Android app, so in that entire project, the first 3, the basic, the starting, the initial 3 simple manageable chunks we are going to take for a sprint. And for that, we are going to write the code. And simultaneously, whenever we complete the code, simultaneously, the testing team will also communicate with the development team, and they will parallelly, they will start testing. Or getting, for example, if you are taking 3 stories per sprint, so if the development team complete 1 story, immediately the testing team will start that completed story for testing. If anything found, immediately they will inform to the development team. Development team, if have any queries, they will directly contact with the customer and they will clarify, and based on that, they will fix the code. Or getting, review, show it to the customer and get the feedback. So, and that after review, it's a launch, release just those 3 features. Whatever stories completed, that 3 feature stories, they are going for release. Are you getting up to this? Are you clear? Is anybody having any doubts over here? If so, please chat, raise your hands. Shall we move to the next slide? Okay. Thank you. Thank you for the feedback. So now, moving to the next slide. Once again. Okay, sorry for the delay. The essential agile terminologies. In agile, usually we use some terminologies to mention some things. Okay, so usually what are the terminologies used for what purpose? Okay, that we are going to see. First, team roles. So what are the roles? Usually we could see in waterfall, we could see the project manager, team leader, and under team, the associates who works under the team leader. Okay, these are the terminologies we used to have, the roles we used to have. Whereas in Agile, we are having a product owner, the role called product owner. A product owner is the one who is the customer, who is going to provide project for us. Okay, product owner. The next one is the Scrum Master. The Scrum Master is not going to do anything in our project. Okay, he is the one who is a coach. So what he will do is every day we supposed to connect. So during the connect, he will an intermediate person who makes to connect all the teams, customers, development team, testing team, infrastructure team, database team, data team. So all teams comes under this coach called Scrum Master, but he's not going to do anything technically. Or getting product owner is the customer who's going to provide project for us. Okay, and project owner, the Scrum Master is the coach who going to manage several teams under him. He's going to guide, okay, what thing we are supposed to, in which sprint we need to complete this one, what we have completed, what are yet to complete, what are comes under backlogs, everything he will monitor. Scrum Master will monitor. Okay, the next is development team. So the development team is actually code writing team. Okay, and they will development team internally, they will do some sort of testings. Okay, and there will be some lot of teams are there. Database team, infrastructure team, API service team, and testing team. So like the data team who will work for test data. So there are n number of teams are there. They will do their own work. Okay, the next, these are the terms, team roles. The next is the workflow terms. So workflow terms, how the workflows are captured. So usually The workflows are captured as user story. User story. Already we mentioned that we are not going to do in Agile, we are not going to do the entire whole project in a stretch. What we are going to do, we are going to break the entire big project into small manageable chunks. That chunks are known as user story. For example, if you are creating a login page, in that login page, design a login button, page to accept the username with only capital letters. This is a user story. Are you getting? So example of user story is, as a user, I want to reset my password so I can regain access to my account. This is a single story. This story alone, we are going to process, provide the code and test and deploy. Okay. Like this, we are going to have n number of user stories, and all these user stories are monitored through some what we tell as agile scrum monitoring tools like Jira, RTC, RQM. Like that, we are having n number of softwares to monitor this user stories. And backlog, the next term is backlog. Backlog is nothing but, for a first sprint, we have some to-do list. Okay, we have taken 3 user stories. If suppose, if not time permits or due to some issues, if we can't able to complete all the 3 stories, we have completed only two story, there is pending of 1 story. That pending story will comes under backlog. Are you getting? Am I too fast?
No, ma'am.
Okay. So backlog is the thing for the current sprint. If anything missed and we are taking that missed story to the next sprint, that user story comes under backlog. And sprint is nothing but usually the period of time releases happen. Okay, usually some companies, most of the companies follows 2 weeks, that is 14 days. Some companies uses 4 weeks, that is 28 days sprint. Okay, usually most of the companies have a shorter sprint only, that is 2 weeks. And the ceremonies, agile ceremonies meetings, there are definitely there will be 3 ceremonies. That is, first one is daily stand-up call, which is run by our team leader or team manager internally. Okay, that is, if we are having a development team, the development team internally run this stand-up call, daily stand-up call. The same way, if we are having testing team will run this daily stand-up call. Like that, every team will generate their own daily stand-up call for every 15 minutes, the first 15 minutes of the day. Okay, the first 15 minutes of the day starting. So in this stand-up call, they will ask for 3 questions. What did you do yesterday? What you are going to do today? And is there any blocking in yesterday work? So these 3 questions they are going to answer. So each and every team member is going to responsible for this, and they are going to update the details, report according to that. And the next meeting is sprint planning. The sprint planning will be happened. Every sprint is happening before the sprint is, that is, the sprint is going to end. The sprint planning will be happening. What are the stories that we are going to taking for the next sprint, upcoming sprint? That is sprint planning. And the next meeting is sprint retrospective. What a sprint retrospective meeting is? In this meeting, we are going to talk about, convey our thoughts in current sprint. What are the things that will went? How we could able to achieve our target? Or if there is any backlogs, what is the issue that makes the backlog to happen? So that everything, what well went, what needs to be done better for next time, that everything will be discussed in the sprint retrospective meeting. Okay, these are the daily meetings happen, daily meetings, ceremonies happening in agile methodologies. The next one is definition of done. So in waterfall model, what we used to do is, if requirement stage is done, then we'll make requirement done. Okay, whereas testing is done, we'll make it as testing is done. Whereas here, the definition of done means in Agile, a task isn't done just because the code is written. If the development is done, then we cannot mark it as the story is done. Only if everything tested, documented, artifacted, that data is ready, everything is ready and deployed at the client side, then only we move that story to done. Definition of done. Are you getting? Is there any doubt in this slide? Agile terminologies, the team roles. Sorry.
Can you re-explain the sprint?
Sprints, that the ceremonies, meetings?
Yeah.
Okay, so the meetings happen in Agile. We used to have these types of meetings. First one is daily stand-up call. Daily stand-up call is the first, whenever you start the day, the first 15 minutes, the entire team should sit together and they are going to discuss what you have did yesterday, whether you have completed all your tasks, that yesterday task, and what you are going to do now, today, what are the tasks you are going to do? And if you can't able to complete the yesterday task, what are the backlog? What is the issue you faced? Why you can't able to complete the task? That we are going to convey to our project manager or project leader. This is stand-up call. Internally, it's going to be happen within our team. If you belong to development team, within our development team, it is going to be happen. If you are testing team, within testing team, we are going to happen. We are going to report to our superior. What we have completed, what are yet to complete, what are the problem we are facing. That is daily stand-up call. The next is sprint planning. Sprint planning is nothing but what is sprint? Usually sprint is a 2 weeks time. So every user story is going to be released at end of 2 weeks. Are you getting the sprint? Could you able to understand what is sprint?
Yes, ma'am.
Sprint is a 2 weeks or 4 weeks time where you are going to give life to your project. So that project is going to be...
Ma'am, there are two more doubts, ma'am, from Ranjit Kumar and one more person.
Please.
First, the question is, the waterfall method is only used for long-term projects in MNC or the Agile also?
Agile also used. If the customer is okay with Agile for long-term project, the best use for long-term project is Agile. Some customers are there, they will only refuse to have, they advise only to have waterfall model for those projects. For those projects, we are supposed to use waterfall.
Okay, ma'am. And there is one more question.
Please.
What is the difference between classic and iterative waterfall model? What is the difference between classic and iterative waterfall model?
Iterative waterfall model is nothing but, so for each and every, for 6 months, they are going to have, okay. Sabrish, if you don't mind, shall I complete this sprint?
Yeah,
then
sure,
I will come to that. Because he is waiting, right? So
Okay,
once I complete the sprint, then I will move to that waterfall. Okay.
Okay, ma'am.
So the one who asked for sprint, have you understood what a sprint actually? A sprint is a 2 weeks of time or 4 weeks of time where you are going to give life to your project. So after 2 weeks, whatever you are done, that is going to be live and users are going to use that project. Okay, so sprint planning, after 2 weeks, whatever you are completed, that you are going to report it here. Whatever things we are taken for last sprint, we have completed. And for the next sprint, what are the stories we are going to accept? We are going to do. That to-do list we are going to decide in the sprint planning. And in the current sprint, if you are having any backlogs, that also added to this next upcoming sprint. Is that clear? Sprint planning. So next is sprint retrospective. And this happens after releasing that software. So if everything is okay and that entire team is going to discuss about what went well. So how we could able to complete all the stories in the current sprint, what makes to happen. And if it does not happen, if you are having any backlog, what are the issues we have faced? For what reason we can't able to complete? Those details we are going to discuss in this sprint retrospective. Sprint planning, we are going to decide what are the stories we are going to take for the upcoming and what are the backlogs already there in the previous sprint. That all going together, and for the next release, they are going to move. And sprint retrospective, if we completed everything, we are going to discuss what well went and how could able to achieve that. Okay, that we are going to discuss. If it does not happen, what backlog we are having, what is the issue caused to have the backlog, that things we are going to discuss. And I think now it's clear. And coming to that waterfall and traditional waterfall and iterative waterfall model. So usually in agile methodology, we are not going to take a month to release a software or getting, whereas in waterfall, even it is an iterative, we are going to take minimum 6 months to release the project. Or getting. So the entire project, what we are going to do is, we are going to break the project. There also we are going to break the project, but we are not going to do in a sprint. That is not in a 2 weeks. Even it is a time consuming only. Iterative is a minimal reduction of waterfall, the traditional waterfall. Iterative waterfall is a minimal reduction of waterfall, but it is not equivalent to the agile. Whereas in agile, every 16 days, we are going to release the project. Whereas in iterative, it takes minimum 6 months to do that. Are you getting? Shall we move to the next? Okay, yes. Thank you. So we are moving to the next slide. Okay, next we are moving to introduction to DevOps. DevOps. Earlier we saw, one second. So before moving to DevOps, we'll have a simple example of Instagram. So imagine you are launching a new social media app. So sprint 1, week 1 to 2 weeks, you build only the login and post a photo features. You launch it to few users. Okay, that will be launched and few users under your circle, that is the nearby the client circle, they are going to use this project and they are going to check for the updates, whatever happened, and they will provide some feedback. If everything is okay, then we are going to launch it for the outer users, okay, outer worldwide, publicly, we are going to make it as visible. So what we'll do in sprint 2, weeks 3 and 4, users say they like it, but they want like photos. So you build the heart button in that to perform that like operation. To post the like, they need heart button. So in the third sprint, they are telling that they are modifying some changes. Okay, they are providing with some changes. So in the second sprint, what you are going to do, we are going to achieve that by implementing that heart button in your login page. The next sprint 3, user wants stories. You build that next. So whatever users want the stories, that we are going to build the next. So based on the user feedback, we are going to work. Then and there, we are going to get the feedback from the user clients. And based on the client's feedback, we are going to work our project. We are not work our project as our own, okay? Each and every moment, there will be interaction between the client. And once the client approves, we are going to move to the next step. If they need any changes, immediately we're supposed to do that changes, implement the changes easily in this agile methodology. The benefit, if the user hates stories, you only wasted 2 weeks of work. If the client does not like that like button, whatever like button you're posting there, if the client is not interested in that, he's not willing in that, he needs to change some other thing. Instead of heart, he needs something different. So you're not going to waste 12 months. Here only we are going to waste 2 weeks of work. You can change direction immediately based on users actually want. Okay, in Agile, we don't wait for a grand launch. We want the users to have working product as soon as possible. And Agile made developers fast. What in Agile, the thing is developers could do that work easily because each and every story is a single minute work only, manageable chunks only. So they will do the work easily and fastly. But the servers were still slow. So the servers, wherever we are going to deploy maintenance, that servers are still slow. So to overcome that, we are getting a new concept called DevOps. So now we are quickly jump into DevOps. So DevOps, introduction to DevOps. The definition DevOps, Dev means development, Op means operation. So operation system, what they will do to system administration and infrastructure teams comes under this operation team. The development team is nothing but the one who's developing the code for that particular project. That team, development team and operation team are going to work together to achieve the entire Agile methodology faster. Are you getting? To shorten the time between writing a line of code and the user using that code while ensuring high quality and ability. And this shows the DevOps concept. The left side is the development side and the right side is the operation side. So development side, plan, code, build, test. So once the testing phase is over, the client comes here and monitors the code. Once everything is fine, if the client okay with that development process, then it will move to release, deploy, operate. Okay, so here the monitor will be act as a center head. So who is going to approve whatever code we have did. So if he is not okay with that, whatever code we have did, then immediately we move to the plan stage. So again, if we give any updation, changes, then immediately we need to plan, code, build, test accordingly. And once everything is good, then we are going to the operation side, operate, deploy, release. Now we'll see each phase in depth. So the dev side, the left side, creation. Okay, the creation part, plan. We already know about from the waterfall model, we are seeing all these phases: plan, code, build, test. In planning state, we are defining the requirements and tracking them. Agile backlog. What are the things that completed? What are the things are yet to complete it? Everything here we are going to report it. And code, developers write the code and use version control. Here Git, we will see it later. Git, everything. So the code, developers write the code. I told you that in this okay. So in this devs concept, right, in the infinity loop, I told you that if any changes needed, okay, for the first time, the client is providing some information. Based on that, we are planning, coding, build, and test. Okay. Based on the client user information, we are going to plan, code, build, and test. Once the first cycle is done, they are going to version that code as V1, V2, V3. If any changes required by the user after monitoring this code, then if any changes required, then that version will be marked as V2. Are you getting here? So this is an infinity loop. If nothing change has been happened, then automatically it will move to the same versioning level. If any changes happen at the monitor state, then the V1 version has been converted into V2. That is happened using the Git tool. I will explain you what is Git later. And build, the code is compiled and converted into an artifact like a Docker image. I'll explain what is image, Docker image later in the Docker section. And test, automated scripts check the code for bugs and security issues. These are the phases at the development side. And operation side, delivery and maintenance, release, deploy, operate, monitor. The code is approved and ready to go to the live environment. Deploy, the code is pushed. Once the code is ready to go live, then automatically the code will deploy to the servers, push to the servers managed by Kubernetes. And operate, the software is live and running for the actual users. Monitor, collecting data on performance, crashes, and user behavior. So he will monitor all the things, and based on this monitor performance feedback, our plan and code build test, everything is going to be modified. Are you getting? Shall we move to the next slide? Is there any doubts in the slide? Okay. Is everything is clear and understandable? Okay. So the next is CI/CD pipeline. I'll tell you what is the interconnection between the CI/CD pipeline, DevOps, and the next coming to Kubernetes. Okay, there is an interconnection between these three things. Okay, DevOps, CI/CD, Docker, and Kubernetes. I will tell you later. This all comes under your agile methodologies. Okay, this all comes under DevOps, CI/CD, Docker. What we are going to see next, Docker and Kubernetes. Everything comes under agile technology. Okay, so first we'll see what is CI/CD. CI/CD is nothing but continuous. CI stands for continuous integration, continuous delivery, or deployment. Okay, what is continuous integration? Developers frequently merge their code changes into central repository. I told you that once the code is completed in that infinite loop, so the code will be version named labeled as versioning V1, V2, V3. Okay, once developers frequently merge their code changes into the central repository. This repository is nothing but GitHub. Okay, I'll tell you GitHub. GitHub is the repository where versioning will be happen for your code changes, and automated builds and tests run every time a change is made. So when developers push their code into the Git, the testers, what they will do is they will design some automation test scripts. Those test scripts should run immediately whenever there will be a code change happen or versioning happen. Are you getting? So whenever there will be a code change or code push happen by the developers, automatically the testing team should run automated test scripts to check if there is any bugs or not. If bugs is there, then immediately we need to raise a bug report to the particular developer through the Jira tool. I mentioned you, right? Some user story monitoring tools are there, Jira, RQM, RTC, like that. So through that tools, they are going to raise a defect if any issues are found. Are you getting this? CI, continuous integration, whenever develop push their new versioning code into the repository GitHub, automatically the automated test script should run and find for the bug. If the bug is there, then immediately we need to raise a defect using the monitoring tool, use case monitoring tool to the particular developers. And the next one is, the goal of this continuous integration is catch bugs early, and continuous delivery and deployment, automatically preparing or sending the tested code to the production environment. Once everything is success, after running that automated test scripts or test scenario, that what will happen? The code, whatever code they have pushed, like version 1, version 2, version 3, like that, the versioning will be there in GitHub. So once everything, the test cases pass, immediately that code should apply to that production environment. That is continuous delivery or deployment. And there is a difference, mild difference between the continuous delivery and continuous deployment. I will let you know later. And the pipeline stages, here also we are having some stages. Source. Developer pushes the code to GitHub. Once the source code is ready, developer automatically pushes that code to GitHub, and In that, if any changes happen, then the versioning will be happen, and that version will be updated to GitHub. Okay. For example, today they are pushing some code with the label V1. Tomorrow, based on that client feedback, they are going to modify a few changes and they are going to label it as V2. And they are going to push the same code V2 into the GitHub. And once this will be happen regularly, iteratively, and build. The code is compiled and packaged, often into a Docker image. So once the code is compiled and everything okay, then it is going to be packaged. And that package is a Docker image. Okay, we'll see what is Docker image later. And test. Automated test scripts to check code for errors. That I told you here is developers, when developers push their code to central repository, automated test scripts will be there. Those test scripts should run and find the bugs then and there. That is, and if the test case passes, automatically the code will be pushed to server, that is Kubernetes. Up to this, are you clear? Am I too fast? Is there any response? Okay, ma'am, can you tell me what is Docker image? Yes, sure, I will tell you in the next upcoming video slides, right? We are going to do that. Analyze why the waterfall model is not suitable for longer or complex software project. I think I already first let complete all those current slides, then we will discuss about this waterfall. Okay, next is continuous delivery versus continuous deployment. Continuous delivery. So here I told you, right, once the testing has happened, automatically the tested code is going to be into a production environment. Production environment is nothing but the client side environment. Okay, they are going to release that code, and the users are going to use that code automatically. Once it is released, the users are going to use it. And here there is a mild difference. In continuous delivery, it needs some human interaction. So once the human clicks, everything is okay, the human needs to cross check, and all the test cases has been passed, then human needs to click final deploy button to come to live. Whereas in continuous deployment, there is no human intervention. If the test cases pass, automatically the code goes to live. Are you getting? This is the mild difference between continuous delivery and continuous deployment. And in all the IT industry, they are using CI/CD pipeline for all the projects. For all the projects, which consumes less time and less expensive. Because of that, they are using CI/CD, where the developers write the code, they will push the code to Git. Simultaneously, parallelly, the testers will test the code and catch the bugs and get the feedback from the customer. And immediately they are going to versioning after completing the feedback changes, they are going to versioning that. Immediately they are going to push. So it is going to be happen iteratively. Okay, because of this, time consuming, more interactive, and less expensive, they are using CI/CD pipeline. If you know this, you are easily grabbed by the IT industry. So next, shall we move to the next slide? Okay, introduction to containers and Dockers. Okay, Docker is nothing but a container. So for example, if you're having a box, okay, a pencil box, where you're going to have pencil, sharpener, whatever things you need for the day in your college or schools or wherever you're going, whatever you're packing for the day, that is a container to hold all the things together. The same way in IT, we are having a container called Docker. So whatever code you're writing, so for that code, what are the libraries you need? What are the database tools you need? What are the settings you need? Everything you are going to combine. What are the runtime environment you need to execute that code? Everything you are going to combine and make it as wrap in a single container called Docker. Somebody asked about Docker. A Docker is nothing but a container where it is going to, see, a Docker container is a lightweight standalone package that includes everything the software needs to run: code, runtime, system tools, libraries, and settings. So everything's are going to be packaged in a single container called Docker. Are you getting? So in waterfall model, we used to have virtual machines. Not only in waterfall model, in Agile also earlier, we used to have virtual machines. Before DevOps, we used to have virtual machines. So virtual machines are the one which is a guest OS. We use some other party tools. Are you getting? Other party tools to execute our hardware or software, whatever it may be. It's some time consuming and it is slow. Now what in DevOps, what they are doing is they are creating a Docker containers, share the host kernel. So there are some n number of, later we will see the Docker thing. So there are some n number of nodes will be there. The host node OS is going to be a kernel will be used for executing the servers. They only contain the app and its requirement. What are the apps we are going to use? What are those requirements for those apps? That details are going to be contained in the host OS kernel, and which is a fast processing server. Are you getting? Containers and virtual machine. Container is nothing but a box where we are going to put all together our code, or what are the libraries that needed to execute our code, what are the runtime environment we need, what are the data we need, what are the infrastructure we need, what are the services we need. Everything we are going to merge into a single box. That is called as container or Docker. Are you getting? Shall we move to the next slide? So why Docker? Why we need Docker? So why we need Docker? Docker is the most popular tool used to create, deploy, and run containers. I told you, right? Once the developers write the code and they are going to push the code into the GitHub. And once the GitHub receive that data, automatically they are going to run some automated test scripts. How they are going to interact? So how, for example, if they are going to execute that files, how these files are going to execute? So using this Docker architecture. So build once, run anywhere. This is the Docker motto. It guarantees that if it works in development, it will work in production. If it works in development side, if it is working in development side and testing side, automatically it is going to work in production side, because whatever things your code need, everything you are provided in terms of Docker file. And in the next step, what we'll do is this Docker file is going to be converted into an image. Are you getting? And this, with this image, you can't going to do anything. It's just an image, JPG file, that's it. But whereas in Docker file, you are going to have all the instructions, how you're supposed to execute, what code you are supposed to execute, what are the files that your code needed, everything will be included in this Docker file. Okay, and in the next stage, what is going to happen is this Docker file is going to be converted into a Docker image. And what the Docker image will do? It do nothing. It's an image of your code, that's it. It do nothing. And the Docker container, this is the one, once the Docker image enters into the Docker container, it will start live automatically. It will start execution. Somebody asked, what is Docker image? Docker image is nothing but a JPG file which impacts the Docker file. The Docker file, see here, the Docker file, the recipe, a simple text file containing a list of commands. It tells Docker, start with Python 3.9, copy my code and run this command. These are the some example commands, okay? Here I provided. So this text file is containing this Docker. Docker file contains this text document, okay? And in the image, Docker image, when you build the Docker file, you get an image. So if you build this, you will get an image. That is the Docker image. It is read-only snapshot. It contains everything, but it's not able to run on its own. Once the image move to the Docker container, it will automatically execute because everything compressed in this container. Are you getting? So in this file, you will mention what type of, what version you need, everything is here. But in this container, that actual files, library files, everything are compressed in this container. So based on this instruction, this image moves here, it will execute and it will get live. This app will get live automatically and it is going to be work on production. Are you getting why Docker? What is Docker file? What is Docker image? And what is Docker container? Is anybody having any doubt in this three topics? Docker file, Docker image, and container? Docker file, a text file which has simple text, what you are supposed to execute, what type of file it is, what type of language you are using, which version you are using. So that simple text file is contains this Docker file. And when you build this, immediately Docker image will be generated. And if you move this image to Docker container, it will get start live. Okay. This is the breathing process of your app project. Is there any doubt in this? Shall we move to the next? So the next one is Docker registry, the library. How we did GitHub? We saw GitHub, right? So whatever the developer writes the code, that code is going to be pushed to the GitHub. And the tester is going to be make use of that code and they are going to execute that code. Okay, it is a hub, GitHub. The same way in Docker, we are having called Docker registry. It's nothing but Docker hub, where all the Docker images are stored. It's a type of GitHub. Are you getting? Once the Docker hub receives the Docker image, it will automatically pulls to the server and it starts to run. How the Docker file moves to the Docker container? With the help of this Docker registry. Are you getting? Am I making confusion? So here we are having Docker file. And when we build this Docker file, we'll get Docker image. And from this Docker image, how it will move to Docker container? We are going to place the Docker image in Docker registry, or Docker library, or Docker hub. Once it enters into the Docker hub, immediately a Docker container will pull that image and start executing that image. Are you getting? This is the use of Docker registry. And why is this so powerful? Immutability and versioning. Once an image is built, it never changes. Once we build an image using the Docker file, if we develop an image, build an image, it is not going to change. If anything need to update in that build, then what we are going to do? We are going to replace with that versioning. Earlier I mentioned in development state, the developer in CI/CD, I explained you, if developers get any update from the client, they will do that updation and move it as a next version. For example, already V1 is there. They are going to move the code as P2. The same way, here also they are creating the Docker image. Are you getting? So versioning, just like Git, you have my app V1 and my app P2. If V2 fails, you just tell the server to run V1 again. It takes a seconds to restart your servers. Are you okay up to here? Is there any doubts? So Docker image, just now I explained. I think you will be okay with that. I still need to explain that.
Ma'am,
So-
all the queries can be had the end, ma'am.
Okay.
Yeah.
So the next, the main, what is still orchestra of your agile technology, the Kubernetes. Introduction to Kubernetes, K8. Okay. So this is the architecture of Kubernetes, the Kubernetes controller. This is the control plane, Kube API server. Whatever the user provide the user instructions received by the Kube's API server, and based on the instruction, it will split schedule to that particular. Here etcd, controller manager, scheduler. 3 events are there. etcd is nothing but database where the data will store. If any data request will be happen, the Kube API server will send that request to etcd, and controller manager and scheduler, this will work together. Okay, how it is going to work is, what is the main purpose of this is, it is going to, the control manager will going to monitor the nodes in this central kubelet servers. Okay, this services, it is going to, control manager is going to monitor which node is running, which node is not working, everything. And if any node is get failed, immediately it will intimate to the scheduler. Scheduler what will do, it will create a duplicate copy of that particular node, and it will restart its service so that it will match the same number of nodes. Are you getting here? So the end user will provide some instruction. That instruction directly sent to this Kube API server. The Kube API server API service will act according to the instruction. If the instruction is data instruction, it will send that service to etcd database, where the data are stored in the database, and it will fetch the data and send to the end user. And this control manager and scheduler, this will work together. The control manager will see the current state and the desired state of the nodes. For example, here we are having 2 nodes. Then the current desired state is 2. If the current state, if any one node is down, then the current state will become 1. Are you getting? The control manager will monitor the node state, whether it is active or not. So by maintaining the tabular column, desired node versus current node. And if any one node is down, then immediately the scheduler, what will do is, it will create a copy of that down failure node and make it run. That is the work of scheduler. And this pod, kubelet, that we'll see in depth later. And cloud provider, everything in Kubernetes, everything will be stored in cloud. And load balancer based on the user instruction and traffic, it will send the instructions to that particular nodes. Which node is free, it will check. And if any node is already having high number of data or tasks to do, then it will move that task to the different node to make it easy. That is the work of the load balancer. Now move to the theory part. So Kubernetes, often called K8 Orchestra, is an open source platform that automates the deployment, scaling, and management of containerized applications. Containerized applications is nothing but Docker applications. Okay, it's an open source platform that automates the deployment, scaling, and management of containerized applications. So now quickly jump into the explanation of each and every component in that architecture. So the Kubernetes architecture, the cluster. The first one is control panel. I mentioned you that the control panel, the brain, the control plane, API server is the front desk. Every command you send goes here. Okay, whatever command the user sending, automatically it's sent to the API server based on that load balancer through nodes. Okay, etcd is the memory, a database that stores all cluster data, the source of truth. Scheduler, the decision maker, it decides which node a new pod should live on based on the available resources. Okay, based on the available resources, to which node we supposed to give the data. That supposed to provide the task that will be done by the scheduler. And control manager, the policeman, it watches the clusters to ensure the current state matches the desired state. Okay, this current state versus desired state we'll discuss later. And the worker nodes, the muscles. The worker nodes is nothing but the center part of the architecture, the kubelet, kube proxy, pod. So these are the actual missions, virtual missions or physical servers where your applications run. Your applications are going to run in that worker nodes, node 1, node 2, we saw in the architecture, right? In that nodes only our app is going to run. Kubelet, the captain of the node, it ensures the containers are running in a pod. So already we are having Docker container. That container, we are going to insert those containers in a pod. A pod is nothing but a smallest unit in K8. it wrappers that holds your Docker container. Okay, you are placing already Docker container is a container where it's going to hold your app. Okay, your code, your what are the supplements that needed by your code. Everything is going to be in a Docker. This Docker is again wrapped into a pod in Kubernetes. Or getting a kubelet, the captain of the node, it ensures the containers are running in a pod. Using pod only, it is going to run. The kubelet is going to monitor that. Okay, pod is nothing but a smallest unit. It's a wrapper that holds Docker container. And kube proxy, the network god, it handles the networking. So users can reach the app. So based on that, we saw that cloud network, right? Cloud. So everything is going to be stored in a cloud. In Kubernetes, all the data are going to be stored in a cloud-based accesses. So that a kube proxy is going to be used. So the next is desired state versus current state. And this is the most important concept in K8. So you provide YAML. So whatever instruction you need to provide to a Kubernetes server, that you are going to give in terms of YAML language. That is yet another markup language. Kubernetes can understand only these languages. Or getting these languages file, YAML file, desired state, I want pod. This is the YAML desired state, I want 3 pods. Like this, we are going to give an instruction to the Kubernetes. A node fails. So already we are having 3 pods. A node fails. Current state, what is current state? 2 pods. Are you getting? Already, initially we had 3 pods. After a node fails, we are having only 2 pods. The controller sees this mismatch. The scheduler picks a new node. I told you, right? The controller and scheduler will work interconnectively. The controller will monitor if there is any mismatch happen in the desired state versus current state, which is nothing but if there is any failure in your pods. If anything happen, it will immediately inform to the scheduler. Based on that instruction, scheduler will pick a new node to compensate that desired versus current state. Are you getting? The kubelet starts a new pod to bring the count back to 3. This is about the Kubernetes architecture. Now we will move to the general Kubernetes terms. So why the name K8? We told initially when we start with Kubernetes, we told us Kubernetes is also called as K8. It comes from the Greek word for helmsman or pilot. Pilot is nothing but the person who steers the ship. The K8 is the entire agile technology as pilot, which is going to run the entire DevOps agile together to make it as faster, easier, understandable, and less expensive thing. Okay, so this is a K8, and the 8 in K8, the 8 simply represents the 8 letters between K and the S. Kubernetes. There's 8 letters combined as K8. The problem K8 solves. What are the problems, major problems that K8 solves? Manual effort, wasted money, traffic jams. Manual effort, you can't manually restart containers at 3 a.m. if they crash. K8 does it for you. Self-healing method. So I told you, right, the controller continuously watches for the desired state versus current state. If any mismatches happen, immediately it will intimate to the scheduler, and scheduler will intimate to the kubelet, and kubelet immediately start a duplicate copy of that particular pod, and immediately the service will be restarted. Are you getting? And wasted money, if your service are only 10% busy, if most of the users are not using your project, then immediately K8 moves containers around to use less hardware. That is bin packaging. Okay, if you are not using most of our memory or processing, then immediately that will be reduced automatically, not physically. Manually, we are not going to do that. It will automatically going to release all the processor which are not in use. Next, traffic jams. K8 acts as a traffic cop. directing users to healthy containers and away from broken ones using load balancing. In architecture, we saw one component called load balancer. When user give the instruction, the load balancer will receive that instruction and it will send to the pods. So the load balancer will check if any pod is busy, then it will move to that move that instruction to the next pod. Okay, by making that decision, it will maintain the traffic jam. It will avoid the traffic jams. So summary, we are moving to the last end of the session. So summary, the future, the big three recap, the Docker, the container, where it is going to comprise everything into a single unit, Kubernetes, where it is going to manage and scales those boxes, and DevOps, the compass, the culture and process that guides everything. Why this matters for your career? Why I'm explaining everything to you guys in your UG standard? Why I'm explaining you? Because in 2026, the highest paid roles are for only cloud and DevOps engineers. So if you are well versed in cloud and DevOps using this Docker, what is CI/CD and Kubernetes, agile methodologies, and you are going to be the highest paid one in your career. So the skills here, you are not supposed to know how to write the code. So we all know how to write the code. For example, if anyone is giving how to write a program to add 2 numbers, we know how to write it. So that is not needed here. What we want to know, how to deploy and scale the code is what makes you a senior engineer. Writing a code, still you are a student. If you know how to deploy it, how to scale it, how to test it, then you are going to become as a senior engineer. I think with this, I'm going to end my session. And shall we go for questionnaire? If you're having any doubts, please.
Participants, if you have any queries to clarify, you can ask the resource person. Either you can unmute and you can speak, or you can put your message in the chat box.
Ma'am,
Yes, please.
ma'am, you are explaining about Kubernetes, right, ma'am?
Yes.
It's Kubernetes. But
Kubernetes.
if we can already manage containers, if Dockers can already manage containers, why do we need Kubernetes, ma'am?
No, inside Kubernetes only, the Docker file, Docker image, Docker container, everything comes in the pod. I explained you about pod, right?
Yes, ma'am. Yes, ma'am.
In that pod only, we are going to place our Docker container.
Okay.
So these are all interrelated. I told you, right? CI/CD, DevOps, Docker, and Kubernetes. In Kubernetes, we are going to interrelate everything together. It's a main outer layer. Kubernetes is the ship steer. Okay, who's going to is a pilot. Kubernetes is a pilot, which is going to ride everything together. Are you getting DevOps? DevOps is nothing but development and operations team. Okay, and Docker, whatever you developed, it is going to be converted into a container. And that container, where you are placing? Inside Kubernetes in a single pod. So each and every application is going to be a separate pods. Are you getting small pods?
Yes, ma'am.
I think, are you clear?
Ma'am, one more thing, ma'am.
Sure, please.
Previously, you were talking about the waterfall model, right, ma'am?
Yes.
But in that waterfall model, there are 2 types, ma'am. One is classic and iterative waterfall, right, ma'am?
Yes.
But in that, I have some doubts, ma'am. Because in classic waterfall model, it's just having that requirement analysis and system design, then deployment, maintenance, testing, like that process, right, ma'am?
Okay.
But in iterative waterfall model, there will be a extra layer, extra part like feasibility to study. But what's that?
Feasibility study is nothing but, so for the first time, that is, I mentioned about your versioning, right, in GitHub here.
Yes, ma'am.
So in versioning, what you are doing? you are going to develop one sort of code for particular changes. Okay, for the user requirement, you have developed one code and you have mentioned it as V1, version 1. And based on that user feedback, you are going to do some mild changes or whatever. Either they are going to replace everything. Okay, so you are going to do some changes to that. Based on that, the feasibility study is nothing but you are going to understand what you did and what you are going to do in the next level. What are the changes you are going to do in the next level? Iterative. So once one loop you have completed, okay, you are going to start the second loop.
Yes,
So
ma'am, yes, ma'am.
what else from this? Already we are having some code. So apart from this code, what you are going to add newly to this code? What are the updations you are going to do?
Okay.
That comes under feasibility.
Yes, ma'am, yes, ma'am. Okay. So
Or
it will be
clear?
it will be inside the in classic waterfall model also it will be there, ma'am, in this feasibility to study.
Feasibility study in classical waterfall model, there is no looping. Okay, once you done
Okay.
one level, that is done. That's it. You can't jump
Okay,
from
ma'am.
lower to higher. It's a
Okay.
downfall only. Okay, from
Okay, ma'am.
requirement,
Okay, ma'am.
design, implement, coding, maintain, testing, implement, deployment, and maintenance. Okay, like this only. Once if there is any issue, again you need to restart. That's it. The entire whatever you effort put, that is going to be waste only. The total effort is going to be waste. Again, you are going to restart. That is freshly. You are going to not restart. You are going to freshly start. Whereas in iterative, you have completed one task, similar to Agile. But Agile, you are releasing the project for every 2 weeks or 4 weeks. Whereas in iterative, it will take minimum 6 months. For whatever, it is minimum 6 months. So till 6 months, you are supposed to wait a project to come live. That is the main drawback there.
Ma'am, but compared to virtual machines or containers faster, ma'am?
Yes, definitely. Because these are all running in the cloud. Containers are running in the cloud. Okay.
Yes, ma'am.
So it will be faster when compared to virtual machines.
So what's the main big difference between both, ma'am? I mean, if you're telling it will be in the cloud, no, ma'am.
No,
But
nowadays, most of the projects are moved to cloud. Every project is cloud-based project only. We are not. Some projects are there, IBM projects like that. Some projects are there which uses virtual machines for few basic reasons. Okay, most of the projects are cloud-based only. For even for our Google also using cloud only for emails, for photos, everything they are using cloud. There is no virtual machines.
Okay.
There's one more question, ma'am.
Please, sir.
Why is Docker widely used in modern DevOps environments? The question is in chat box. Why is Docker widely used in modern DevOps environments?
Because in DevOps only we have introduced a concept called Docker containers. Earlier DevOps, prior to DevOps, there is no concept of containers. So what we do is, so each and every machine, for example, if you are writing a code, it is going to work in your machine. If it is containers not there, you are writing a code and it is going to work in your machine. If you are the same code you are transferring to the testing team or some other team, it is not going to work, because whatever configuration, whatever data, whatever database, whatever version you have used will be different from the others one. So I told you, right? It works on my machine syndrome, a concept. Because of that lack of Dockers only. In DevOps only, they have introduced the Dockers, containers, and using containers, we have overcome this. It works on my machine because Docker, what the Dockers doing? Whatever supplements that needed for your code, everything they are putting in a container. So that container we are going to kept in a pod in Kubernetes. So once the Docker file reach the container, it automatically your app is going to be executed. So before DevOps, there is no concept of containers.
Okay.
It's a standalone. So each and every one, for example, if the development team is writing a program and they are executing fine, They need to check with the development team, what are the configuration they are having, what database, what version of database they have used, what infrastructure they have used, everything we need to set up in our system. Then only we can make that code to work. Otherwise, it can't happen. So whereas in DevOps, they overcome that issue with the help of that containers.
Okay, ma'am. Fine. So I think there is no more queries, and one more last query, ma'am.
One
Yeah, why is a Docker image described as a read-only snapshot?
Once the build has been generated, we can't able to execute. Even in our normal day-to-day life, we could able to see some files which can't able to execute by ourselves. We can read only those things. Are you getting? But that will be a special purpose files. It's a snapshot, that's it. Once that move to that Docker container, then only it will get a live. Then it start executes. What actually what it is, we can't directly send the Docker file to the Docker container. So we are making that Docker file into an image file, and we are sending that image file to the Docker container. Docker container will scan that image, read the instruction, based on the instructions, use the supplements, and it will start execution.
Okay, ma'am. So I
one
think
last question, ma'am.
last question, ma'am.
Sure.
Ma'am, you have shared one model, no, ma'am, in that Kubernetes previously.
Yes.
In that there was a part that Kubernetes, no, ma'am, inside that.
Kubernetes pod. Kubernetes will be inside the pod.
There are multiple nodes, no, ma'am, in that. If in that any one node, one kubelet stops working, means what happens?
No. Kubernetes will not stop. Kubernetes will not stop. See, the kubelet is the captain of the node. Okay. It ensures the containers are running in a pod. If any pod is failed, then the kubelet starts a new pod to bring the count back to 3. Here we said, right, desired state versus current state. The kubelet starts a new pod.
Oh, okay.
Kubelet is the captain of the node, and the node in that node, the kubelet is the captain. It is going to check if every pod is running properly. If any pod is missing or failed, then immediately it will restart that pod and make it the counter, desired state versus current state matching. Are you getting?
So it stays working.
Kubelet will not fail. Kubelet will not fail. It will monitor the pods. Which pod? Internally, each and every node has kubelet.
Okay. Thank you.
Architecture. Let's see this. So each and every node, node 1 is having kubelet, node 2 has kubelet. Pod, the container, runtime containers. Okay. So if any pod is missed, okay, in this we have pod, right? So this kubelet will check for this pod running state. If the current state of this pod is failed, then automatically it will check and do some things, and it will restart this pod to make it work. I told you, right?
Okay.
It will the benefit advantage of.
Okay, ma'am. So let me come to the conclusion. So now I call upon Sriniti, first MCA, to deliver the vote of thanks. Sriniti, over to you.
Good evening, everyone. I'm Sriniti, and it's my privilege to deliver the vote of thanks for today's seminar. On behalf of our institution, I would like to express my sincere gratitude to our respected guest speaker, Ms. Chandi Rani Janardhanam, for delivering such an insightful and informative seminar. Her valuable knowledge, experience in the field of software development and testing have truly inspired all of us. Thank you for taking the time to share your expertise with us, ma'am. I would also like to thank our respected director, ma'am, HOD, ma'am, and all the faculty members for the consent, support, and for giving us the opportunity to conduct this seminar successfully. A special thanks to all the students and participants for your active participation and support. Once again, thank you everyone for making this seminar a great success. Have a wonderful evening.
Thank you, Sriniti, and thank you, Chandirani, ma'am. Participants, the feedback link has been shared in the chat box of Zoom. So kindly fill the details without any mistakes. So you'll be receiving a e-certificate within 1 day. Okay.
Thank you, Sabri sir.
Thank you, ma'am.
For providing me this opportunity.
Yeah,
thank you, Usha, ma'am. Sabri sir, if you don't mind, shall I?
Yeah, Michelle, you can leave, ma'am. Thank you,
Okay,
ma'am.
thank you.
Yeah,
Thank
yeah.
you.
Ranjit Kumar, you can just personally chat me in the WhatsApp so I can able to clear you or some other doubts if you're going to have it.
Yeah, okay, sir.
Yeah,
So
okay.
she is a experienced person, so only I asked to her.
Okay, ma. No issue, no issue. Participants, once again, repeat the feedback link is shared in the Zoom chat box. So fill it fastly. You can receive a e-certificate in 1 or 2 days. So those who have filled the feedback leave can leave the meet, ma. Participants, still you have not filled the feedback link, kindly do it.
Sir, while I joined the meeting, actually my phone has took my phone device name as in the Zoom meeting. That's not a problem, right, sir?
No, ma. You had filled the feedback link, right?
Yes,
So
I filled
concerned
it,
mail
sir.
ID will be sending the e-certificate. Most probably today night will be sending you, ma.
Okay, sir, because my device name OnePlus not is it took so only, sir.
No issue, pa. No issue.
Okay, sir. Thank you, sir.
Yeah. See, those who have filled the feedback link can leave from the meet. So I'm going to end the session.